Assalamualaikum warahmatullahi wabarakatuh. My name is Wan Ain Fahadia bin Hassan. My method number B08210104. So today I would like to talk about the question given about the transfer function. Firstly, we need to look what is a transfer function. The transfer function omega h of a circuit is the frequency dependent ratio of a pulsar output, which is omega y is an n element voltage or current to a pulsar omega x, which is source voltage or current. So this is a block diagram for a transfer function, which is input omega x and the process is a linear network omega h and the output is omega y. So the formula to find a linear network, which is omega h, is omega y divided omega x equal to omega h. The frequency response of the circuit can be obtained by plotting the magnitude and phase of the transfer function as the frequency varies. So the formula to find the omega h, we need to divide the omega y and omega x, so we get the answer, which is the omega h. It also can expressed by use to find the omega h. We need to divide the omega n divide omega d. So omega n, which is a numerator polynomial, and omega d, which is a denominator polynomial. Next, we move the what is a Bode plot. Bode plot is a similar plots of the magnitude in decibels and phase in degrees of transfer function versus frequency. In a transfer function, we have a communication in a transfer function in omega h. Firstly, we have a gain k. Second, we have a pole omega j or 0 at the origin. And then we have a slipper pole or 0. And lastly, we have a quadratic pole.
Assalamualaikum warahmatullahi wabarakatuh. I'm Muhammad Azril from Beei, and this is a question 1 for my group. What is the question 1 is can give the transfer function and also the Bode plot. And what we do for the question is we must to convert for the transfer function to the Bode plot, and this is method how to do it. And the firstly how to do it is we must to convert for the general form to the standard form. This is a general form and also this is a standard form. And after we can get the standard form, we just change the j omega to equal to s, and then after that we go to factorize, and what we get, and also the answer is the h omega equal to 10 j omega per j omega over 2 plus 1 and j omega per 10 plus 1. After we get this equation for the standard form, and we can change for the something like equation to for the similar graph as HTP equal to 20 log 10 plus 20 log 10 j omega negative 20 log 10 j omega over 2 plus 1 and negative 20 log 10 j omega per 10 plus 1. Okay, and after we get the equation, we can draw the graph. This is the result graph for the magnitude graph and also phase graph. After this, I will show you how to draw the magnitude graph and also the phase graph.
Hi, my name is Muhammad Danial, and I will explain about the process of Bode plot to transfer function. This is our question, which is question 1. The first step to do the process of Bode plot to transfer function, we need to find and observe the corner frequency. To identify the corner, we need to look at our graph that lead to 5, 10 and 100. After we identify the corner frequency, which is omega 5, 10 and 100, we need to change the omega to the standard form. After that, we need to key in the standard form to one equation, which is lead to hs equal to k s over 5 plus 1 over s over 10 plus 1 s over 100 plus 1 to the power of 2. After we compute the equation, the answer will be hs equal to 20,000 k s plus 5 over s plus 10 s plus 100 to the power of 2. After we find the corner frequency, we need to find k by using gain formula. To find k, we need to write down the formula, which is gain equal to 20 log 10 k plus minus gradient of first line log 10 omega. After we put all the information, the final answer should be k equal to 10. After that, we have to substitute the value, which is we have to substitute the value of k with 10. After we compute the equation, the final answer will be 200,000 s plus 5 over s plus 10 s plus 100 to the power of 2. And this is analysis part. This summary shows how to identify the magnitude and phase for each factor. So in order to create a Bode plot to transfer function or transfer function to Bode plot, this is the guidance on how to identify for each factor.
My name is Aqillah binti Muhammad Skifli. My metric number B0822105884. To sum up overall, we could understand a transfer function is represent a relationship between the input and output signal. And we know that the Bode plots also represent a frequency response of system. They consist of magnitude and phase plot that provide insight into the system gain and phase shift at different frequency. Bode plots are useful for analyzing stability, resonance, and frequency domain characteristics. They represent a simplified analysis, faculty stability assessment, and educational as well. By analyzing transfer function and Bode plots, we can gain insight into system performance, stability, and frequency characteristics. They can identify critical frequency, design appropriate compensator or filters, and optimize system response and stability. We can determine the transfer function, then we also can learn how to plot the Bode plot from the transfer function as well. Lastly, for this project, we know about a Bode plot is a graph that represents the frequency response of a system. It shows the magnitude and phase of the transfer function as a function of frequency and can be used to analyze and design control system.